I'll be talking about how we can write REST services using gRPC Gateway. Yeah, so we know, right? I'm assuming that you have been like experienced with writing as hello world gRPC service. We define protofiles and generate stuffs and all. But what if like we want to run gRPC? gRPC power to REST services, REST clients. Like what if we want to have a SDK we support REST, but you want the power of gRPC into it, advantage of gRPC. So how we can do that? So there is a tool called gRPC Gateway. What it does is like it generates REST API endpoints for your gRPC services and vice versa. So this is the agenda for today. So I will be discussing what is gRPC Gateway, how it works, and how different types of mapping we can do, and how we can write a simple hello world service and get the two endpoints, gRPC endpoints, and with the same service REST endpoints, and then advanced features gRPC Gateway provides. So gRPC Gateway is a project of gRPC ecosystem. So we have an organization called gRPC ecosystem, which has a lot of projects related to gRPC, like gRPC middleware, gRPC gateway, and a lot of maintainers contribute to it, either from Google or gRPC maintainers. So I was the so about myself. So I work as a level 3 engineer at Moller Maersk logistic company. I'm part of platform engineering team in Bangalore. So mostly I work in Go and backend services. So how I came to gRPC Gateway is back in 2020, back in college days. So I was the senior of docs mentee for gRPC Gateway, and from that time I've been contributing to gRPC Gateway project. So yeah, I've worked previously at a startup called Lumo, the bus, Red Bus, and Economize. I've been mentoring for G-Shock for last couple of years with Jenkins CI org. Yeah, so let's start with what is gRPC Gateway. So basically, in general, it's a plugin for protocol buffer compiler, Protoc, which is we use to generate the stubs. So basically, this plugin reads your gRPC service definition and automatically generates a reverse proxy server for you. So how it works is like this is a reverse proxy sits in front of your gRPC service. So whenever a person or a client does a HTTP request, which is a JSON request, the proxy translates them into gRPC calls, and then gRPC does whatever the logic, and it returns back to the JSON response to the client. So these all conversion transcoding happen via gRPC gateway. So the best thing is that you write your service definition at once. So we define a protobuf file, we write our service in once, and you get a gRPC by native and also the REST APIs for the same service. So two things we can get from that, the gRPC APIs and REST APIs. And also, plus it generates OpenAPI docs. So we by natively gRPC Gateway generates the Swagger documentation for your REST API. So you don't need to care about those API documentation and all. So as I mentioned, like this is not a hack project. So many companies has been using and contributing this project like Square and Netflix. Yeah, it's a production to solve production level projects to solve millions of API requests in every day. Let's move to how it works. Let me walk through the basically life cycle of a request. So like let's be I have a REST client, and it makes a request to. So first we write a proto service, right, in gRPC. I will mention how we update the proto service to make it compatible with gRPC gateway. So we have a proto service proto file. We do some configuration there to make it REST compatible. After that, we like REST client sends a HTTP request to this service. So this gRPC gateway proxy knows exactly how to translate that request to gRPC. And how it does is like we have a annotation file called Google HTTP annotation. So these annotation has a set of rules. So if gRPC message status has to be converted to HTTP status, how it has to convert it, how to map the put gRPC message to put request or get or something like that. Because we are converting to HTTP 1 to HTTP /2. So those some methods, some standard has to be defined in some file. So we need that file to make this happen. And then the proxy, which is a gRPC gateway, forward this gRPC request to actual gRPC service, the main service. This is the same service that native gRPC clients talk to. and your service process the request, sends back the gRPC response. So this is the gRPC response. We need to convert back to the JSON response. Again, the gRPC gateway convert it back to the REST client. So yeah, I mean the best part is in process for regular unary calls. So we have a two streaming gRPC native and REST, and this is the diagram for the lifecycle of a request. How API client, REST client make a request, which is like a put and then go to the reverse proxy and gRPC and back to that API client at end. So how we can, what things we need to change to make this happen? Like how we do the mapping to make it happen. So there is four ways as of now in gRPC gateway. We can do the mapping. So which is inline annotation. We can define some configuration in the same proto file to make this happen. Or you can define if you don't want to disturb your main gRPC proto file, and so you can have a YAML file where there you can define the configuration. I'll talk about the configuration, what things we need to add. And also, like if you don't want to do anything, automatically also it auto generate your REST endpoints, and also the multiple STP bindings. So I will go one by one. Let's start with the inline annotation. So this is a simple gRPC protofile data service, and I have added some things in between. You can see post, body, star. As start, you can see we are importing Google /API/annotation.proto. So that is a file where the rules are defined, how mapping has to be done, how to take gRPC messages and convert it to understand it to like REST standards. So also you can see here we have specified post slash v1 slash hello. So basically, which means when someone make a request to post slash v1 slash hello, it will call our say hello gRPC method, and body start means it will take the entire request body, because gRPC doesn't have something called bodies. It works like a message. So we need to and HTTP the data is passed via body. So we need to put a star there to take the entire request body, all the parents and all those stuff. And yeah, I mean this is a simple hello world. We can customize to different HTTP methods. It support all patch, get, put. So accordingly, we update the protobuf file. You can go through this how we can do. Even we can have versioning and all those stuff into the docs. So we update the proto file in inline annotation, the same proto file we use in gRPC service. What if like you don't want to disturb your proto file? You want to define these things in different file. So you can do it via YAML. So we make an YAML file and there we define that the same way. So you can see slash v1 slash hello body. So it will be in YAML format, something like that. So you can see a type google.api.service. So this is the approach is great when you want to keep your profiles framework agnostic, or when you're working with profiles, you don't own or you don't want to modify or something that. So still you get a full customization of endpoint methods and body mappings, as you can see. And as a third is like if you don't want to specify anything, like this is the simplest but least flexible option. No annotation, no YAML files, nothing. So when gRPC gateway sees a method without an HTTP annotation, it automatically like generates a REST endpoint based on the default pattern. And the endpoints follow a convention based on your service and method names. For example, say hello method might get auto-generated to something like post hello.v1. It won't be according to you, like so. That's a weird like you don't have that power to customize the stuff. It will be auto-generated. Uh, and the format depends on the generator settings, the proto. It's good for like if you want a demo project or prototyping stuff, you don't want to define all the custom stuff, so it's good for those things. And the fourth method is advanced approach using multiple HTTP bindings. So this is really powerful. So it lets you to expose your same gRPC method to different, multiple different REST endpoints. So we use a additional underscore bindings feature inside a Google.api.http annotation. So in our example, the say hello method can be called three different ways. Post slash v1 slash hello with JSON body, get slash v1 slash hello name with the name in the URL path, and or post v1 slash greet with JSON body. And all this, like all three endpoints call the exact same gRPC method. And this is incredibly useful for like if you want to have API versioning or sort of like supporting legacy endpoints. Like if you have an endpoint you don't want to disturb, you want that in same way. You don't want to update the method just to not to break the things. So you can use this. So this provides multiple ways to call the same functionality for different client preferences. And you might use get for simple lookups or post for creating resources or provide both for backward compatibility. And this is flexibility is very amazing. One implementation and you get a multiple REST APIs. So let's have like you have a service or gRPC service or simple hello service. So you want to have HTTP REST power into it, like a REST endpoints for also. So how we can how what things we need to do, what things we need to configure to make it happen. So so simple. So it's simple. So I will show you example of hello service. I won't be adding a TLS stuff and all. It will be a very simple example. So I'll be using a tool called Buff. So Buff. We generate stuffs via protocol compiler. That's how we generate. But normally, if you see on production level projects, there is tooling and linting stuff. Buff is a company, so it's a modern tooling ecosystem that helps to generate the stuffs. Also link your proto files and all those stuffs. So I'll be using a buff to make this happen. So I will be defining a gRPC proto file and I'll be updating a main.go file to have our gRPC gateway server along with your gRPC server. And so let's go to the first file. This is a hello.proto and I have added like so I'll be using inline annotation. We are importing the annotation proto file. This what enables a gRPC gateway functionality. And also notice the option block inside the say hello RPC method. So that's the HTTP annotation that maps this gRPC method to the REST endpoint. And what we are saying here is like when someone makes a post request to /v1 slash hello URL, it calls a say hello method and then means take the entire body request to map it to say hello request message. So we can customize accordingly URL path, query parameters, and all stuff. And the message definition is simple. Say hello request contain just a name, and say hello response return a message field. So yeah. So next, this is a proto file. We change it to make it to a REST endpoint. So this works in both gRPC and REST. Now we need to define our buff.yaml file. So what dependency we need to make this happen. So we need Google APIs because we are importing that annotation http.proto. So that is maintained by Google. So we need to import this registry stuff. And also I'm importing one proto validate. It's not needed. I'm importing because to like make the proto file well defined. So if you use this validation stuff, it will say your proto file is not version or something. So just for extra tooling. And also like I have the lint rule standard file load snake case. So using buff, you can define these rules to make your things more accurate, standard production level stuff. So when you run buff generate, it will generate your all the stuffs. So all your files will be generated hello.pv.go, hello.pv underscore pw.go. So when you generate stuffs via gRPC service, I think two files are generated .go files where your code handlers and all will be defined. Now one extra file will be generated, which will be a gateway, a gRPC gateway file. So 3 or 4 files will be there .go files. So this is the buff.gen.yaml. How things will be generated. The first plugin is like protocol buffer/go. So this generates a protocol buffer message types in Go. The second plugin is gRPC/go. So this generates gRPC client and server codes. I mentioned the code, pv.go that file. And this is the main thing. The third plugin is gRPC ecosystem/gateway. So this generates REST proxy code that translates HTTP requests to gRPC calls. And this plugin uses the path equal to source underscore relation option. So which means generated files will be placed right next to their source proto files. So keeping our project nicely organized. And so these are the configuration files to generate the stuffs. Now let's go to the main.go file. So which will where we like implement our actual server. So this embedding the Go best practice for gRPC services. So it ensures that if new methods are added to the service definition future, our existing code won't break. So the say hello implementation is straightforward. It takes a context, say hello request, and a say hello, and returns say hello response. We are simply formatting a greeting message with the name provided in the request. Notice how typeset that this code is, so we can't like accidentally misspell fields names or use wrong types. So the Go compiler catches all of them at the compile time. And let's move to the main.conf CM file. So this is a run gRPC server. So I'm running on 5005 port, and like it's a basic, like we create a TCP listener on port this port, and then we create a new gRPC server instance registered at greeter service, and simple how we write a gRPC service, and we call this via gRPC call these things. So let's move to the next servers, the gateway server. Along with that, we create a mux for the gRPC gateway runtime package, and then we call registered greeter service handler from endpoint. So this function automatically generate by the gRPC gateway plugin the pv.pw file. In that, this function would be there, and we tell it forward all the HTTP requests to gRPC server running on localhost 5005. So whatever the request coming there, it will forward it. So finally, we start a standard HTTP server on port 8080. So this port handle all the like REST requests. And now we have two servers running, the gRPC server and the new service REST gateway on port 8080. And both are talking to the exact same service, the gRPC service. But we are getting the two power, the gRPC and the REST. And yeah, I said like this for demo, so I'm not using any insecure credential here or TLS stuff. Now, when you run this service main.go, go run main.go, the two server will be run on different port, and you can test it using gRPC curl, as you know, and REST client test when you run this call request, so it will give a response. Hello gRPC conf. So all the codes will be in the repository. I will share it up at the end of the talk. And so yeah, I mean, both calls return the exact same response, hello gRPC conf. And why? Because both are calling the same hello, say hello implementation in our code. Uh, so one request went through gRPC protocol and the other HTTP with JSON, but they both executed the same exact same business logic. So that's the power of gRPC gateway. So write your code once, serve it in both ways. Let's move to some of the advanced features it supports. So gRPC gateway supports so custom HTTP mapping, streaming support, error handling, and etc. So I will go through one by one. So first advanced feature is custom HTTP mapping. So this is super powerful. So you can build REST API that feel like exactly traditional REST API, but powered by the gRPC underneath. So for example, you can use path parameter like /v1 /users /user ID, where user ID gets automatically extracted from the URL. And this is a common REST API. Like when you do get user /123, you get the user with ID 123, all the details stuff. And you can also control what goes in the request body versus what comes from the URL. For instance, when you are updating a user, the user ID comes from the path /user /123, but updated user data comes from the JSON body. So you can map all the standard REST HTTP methods: get for reading, post for creating, put patch for updating, and delete for removing. This means your API follow REST best practices while still being gRPC under the hood. So it's the best of both worlds. Let's move to the next, streaming support. So this is one of the main thing. So think about the scenarios where you need real-time updates like live logs, monitoring dashboards, or server-side events, stock prices, like that. So gRPC has built-in streaming support. So when we define a server-side streaming, RPC in Proto, gRPC gateway exposes it to REST client as chunk JSON streaming. So using a ND JSON format and new delimited JSON it stands for. So each message in the send as its own chunk using transfer encoding chunk. So gRPC give streams one by one, and gRPC gateway translate it on the go. So there is won't be a buffer flush and all. So it's better than the traditional REST, because in traditional REST, if streams comes in, it is to combine in a one JSON and send it as one. So I won't say it is a like a real stream. So this has a real stream, server side stream as compared to traditional REST. And this works perfectly with curl, postman, anything. So the gateway flushes each JSON objects immediately. So like message hi, then message hello again, and so on. Uh, and yeah, gRPC native clients get full streaming capabilities. So Unity server-side client bidirectional. We don't have bidirectional and client streaming in this gRPC gateway, because it doesn't make sense, because these things are based on HTTP/2 and REST is based on HTTP 1, and we have like limited in HTTP we have a limited size body we can send. So it's no support by default. So and REST clients only receive server side streaming because I said like HTTP 1.1 cannot have that wide streaming support. Important note is like if you specifically want server-side events format with data, textures, and content type, like text like event stream, you need to manually wrap the gateway chunks. So whatever response coming from the gateway, you need to wrap it somewhere to make this to get the server-side events. So by default, it outputs ending JSON, new delimited JSON, which works great like most of real-time use cases. So the big benefits is writing streaming once. gRPC get full streaming while REST clients get real updates too. And this is perfect for real-time dashboards, analytics, and any scenarios where servers needs uh, to push data to clients and as it becomes available. Error handling. So third advanced feature, error handling. So when things go wrong in your application, you need to tell the client what happened in way they understand. gRPC has its own error code like not found, invalid argument, or internal, and HTTP had different status code 404 not found, 400 bad requests, 500 internal server. So the beautiful thing is that gRPC gateway automatically translates these. So when you return gRPC not found error in your code, gRPC client gets the proper gRPC status codes. So how it knows this has to be mapped to this? So via that file, the google.api.proto file. So they have defined that okay, this is this, map it to this. So via that file, it's going to happen. And but REST clients automatically get HTTP 404. So accordingly, you just map it. This means you write your error handling once in gRPC status codes. So you don't have to worry about anything. Whether gRPC or REST gets error in format they expect. So the error message are preserved too. So everyone gets a meaningful error information. It just like works via that file. Yeah. So code.not found, which is gRPC, will map to the HTTP 404 or so accordingly. So don't have to care of the error handling. Yeah. So this is about the advanced feature of gRPC gateway. This is the key takeaways about that. So gRPC gateway is a powerful tool. So if your service has gRPC support and you want that same service to have the REST endpoint too, for some reason maybe you want to call via curl or you want to call those service to the different REST SDKs, but you want a powerful support of gRPC because when you write this service in a native REST, it will be slower than this. So write your service REST and make it happen in gRPC and REST at the same time. So this means your internal microservice can communicate using gRPC for maximum performance and efficiency, while your external clients like a browser or maybe a mobile app can be familiar with REST API or JSON. Also, you get OpenAPI docs on the go, so you don't have to care about the docs. And yeah, I mean, the most important is massive time saver. So instead of maintaining two complete separate APIs implementation, that easily can drift away and cause bugs and all, you maintain just one protobuf definition and less tools handle the translation work for you. As I mentioned, like you can run in the web browser. There's also a project called gRPC Web, so, I mean, it's good for web browser, but it doesn't support if you want to run on some clients or mobile apps or via maybe a CLI curl or something. So, gRPC Gateway is more like a generic project, more, I mean, used by many companies. And yeah, I mean, you can also like go and contribute to that project. Like it's obviously open source and a lot of issues and support roadmap things are going on. Like, so feel free to check out that project. Uh, this is the references. You can go to the this repo or websites and also to scan the QR to go to the repo. So all the slides and all the hello and I mentioned the codes. You can go and play around it. It's very simple. It's a make file, run it, and just play around gRPC using gRPC call and call with the rest stuff. So yeah, so these are the links. And yeah, thank you so much for listening to me.